So this next kind of word problems are geometry problems, and really the basis for these ones is given to you on your formula sheets or the inside cover of your textbook. There are some common geometry equations, and you don't have to have them memorized. Those are tools for you to have at your disposal. The key with these geometry problems is that I really like to draw a picture. I like to illustrate. If it's a question about a rectangle, draw the rectangle and label on it what you know about x and x plus 4, or whatever information it gives you about this. If it's a triangle, label it. Label as x and 2x and whatever this one is down here. In drawing the picture and then using these equations as a framework, it allows you to build up the equation. It allows you to give your let statements, and then it allows you then to make the equation to solve. All right, so I'm going to try and model that in these ones. In number 1, it says the length of a rectangle, so this is about a rectangle, I'm going to draw a rectangle, is 1 less than 3 times the width. The perimeter is that. Okay, so I've got my rectangle. I know that the perimeter of a rectangle is twice the length plus twice the width. That is my framework equation here that I'm going to use to build my equation once I've labeled my diagram. So the information says that the length is 1 centimeter less than 3 times the width. I am comparing to the width, so width gets to be the x. Now I need to take this and come up with what is the length here. It says it's 1 centimeter less than 3 times the width. And so 3x minus 1 would be the length, and x would be the width. So now that I've got this drawn and my framework equation given, it says that the perimeter is 54. So I'm going to follow the framework to build my equation. 54 equals twice the length plus twice the width. And I just use the length and the width off of my diagram here. So now that I've done this, I have the equation that I can solve. So I have my let statement, I have my equation, and now I need to do distributive property and solve for x. Gather up my x terms on that side. So 6x and 2x is 8x. I'm going to leave the 8x on that side because it's a lot of work to put it on the other. I think usually by this point, you're starting to develop the skills that you don't have to have the x's on the left. And I get down to that x equals 7. Now, this is not the answer. I need to take this 7 back to my let statements to give the final answer. So the width is going to be 7, but the length is going to be 3 times 7 minus 1. So 21 minus 1, or 20, just doing my rough work. So the rectangle is 7 centimeters, don't forget the units, by 20 centimeters. Or you could say the width is 7 centimeters and the length is 20 centimeters. Okay, so we're going to do all of these geometry problems in this same way. We're going to draw a picture. We're going to come up with the framework equation that's in our formula sheets or on our textbook or given to us, and we're going to develop the equation from there to solve the problem. So this one says it's another rectangle. It says the length of the rectangle. So let's draw the rectangle. Gives me some information about it. It says that the length is 5 inches more than twice the width. I'm comparing to the width, so again, this gets to be x. And I'll give you a minute to come up with the expression for the length. I get that it's 2x plus 5. The next sentence of the equation or the question says that the perimeter is 76 inches. So that's going to be, again, the framework equation that I use to put the specifics from my picture and the question into the equation. So the perimeter is 76, sorry, equals 2 times the length, so that's 2x plus 5, plus 2 times the width, so there's a 2x. Okay, so in solving this one, I need to use distributive property to crack open those brackets. It'd be 76, I want to say that wrong, 4x plus 10 plus 2x when I get down to the bottom, I get that x equals 11. And I need to take that back to my let statement so that I can give an answer. Obviously, the x is going to be 11, but the length I have to do some figuring on. So that's 22 plus 5 or 27. So the rectangle is, it asks for the dimensions of it, 11 inches by 27 inches. Your textbook is American, so anytime I changed it to centimeters, but a lot of these stay in imperial because I didn't transpose them when I wrote out the notes. So C, you should be kind of catching the hang of this one. Again, it's about a rectangular playing field. So let's draw the rectangular playing field. Again, this one's going to be about a perimeter. We're going to use our picture to illustrate our X statements and then use the framework equation that we've been using to build our formula. So this one says that the length is 5 less than twice its width. So we're comparing to the width, and 5 less than twice its width. These seem really, really repetitive. Oh, it was more than. That was almost the same thing. Okay, so coming up with my equation, 230 is the perimeter, 2 times the length plus 2 times the width. Looks like that as an equation. And then I'm going to solve my equation to figure out what x is worth. Gather up the x terms. Add 10 to both sides. And I get down to that x is 40. So one more time, that's not my final answer. I need to take it back to my let statement to actually figure this out. So that's going to give me a 75. So the field is 40 feet by 75 feet. In all of these, I've tried to give you, 3 that were really similar and then move on from there. So this one's going to be a little bit different, but we're going to use that same strategy. So this one says that a box has a volume of 36 centimeters cubed. So let's draw a box. And volume, we're considering the 3-dimensional shape of this box. We know that volume is equal to length times width times height. And if you didn't know that, that is on your formula sheet. So when you see volume of a box, find your framework equation. This one's going to tell us some more pieces of information. So we know the volume is going to be 36 centimeters, but it also says it has a height of 2 centimeters and a length of 6 centimeters. What we don't know is the width, and so that's going to be the x. And if you draw a picture, that can count as your x statement. If you want, you can say x is the width, or let x be the width, or whatever. So coming up with the equation, fitting the framework, it says the volume is 36, and the centimeters cubed is just the unit. So we've been dropping the units from our algebra. The length was 6, and I know it, so I can put it in. The width was x, we don't know what that one is, and the height was 2. My writing was really messy. That says centimeters there. It's not another number. So now that I have this, this is my equation. What I'm looking to do is solve for x. Well, I can gather up my like terms or kind of simplify this side a little bit, and then I would know to divide by 12 on both sides. So I get that x equals 3. And I was only looking for one thing here, so the width of the box is 3 centimeters. I really like the geometry ones. Maybe it's because I get to draw a picture. Maybe it's because it has the framework equation given to you. And it's really about putting together the specifics of the question from the picture into that framework that builds your equation. So those ones are your geometry word problems.